Hello students, this is lesson number 5 of unit number 2 and today we are going to learn about cumulative distribution function. This is a very small topic and if you remember in the previous lesson we discussed about the random variables and we learned that we have two types of random variable, discrete and continuous, and then we learned about their probability functions. Okay, so if we have discrete random variable, then its probability function is known as probability mass function, or in short PMF. And if we have continuous random variable, and its probability function is known as probability density function, or PDF. Now I am talking about cumulative functions, okay, cumulative distributive function. So as I told you that this cumulative function is very closely related to probability functions. So that is why we are going to learn about CDF, in short, cumulative distribution functions, for both the cases, when we have discrete distribution and when we have continuous distribution. Okay, so let's begin first of all with the definition of this cumulative distribution function. This is a very general definition here, because see here, let x be a random variable. Here we are not talking about any discrete random variable or continuous. We are talking about in general. Let x be a random variable, then the function capital Fx defined by Fx equals to probability function capital X less than equals to small x. Okay, what is small x here? Small x is a certain number, okay, any arbitrary certain number within the range. This basically this Fx is called the distribution function of x. It has the following properties. I will discuss these properties. And this Fx is also called the cumulative distribution function of x. Okay. In this definition, I have used two things. Fx is known as distribution function and also known as cumulative distribution function. Because in some books, you will find only distribution function, not cumulative. So you must be very clear that these two things are same. Okay, but the definition is, as I told you, that CDF basically depends on the probability function. So that is why the definition says Fx is equivalent to probability function x less than equivalent to certain number of x. Okay, and here now I will tell you means how this CDF takes place in the discrete random variable. Okay, so here, in the case of discrete random variable, discrete distribution function, or simply CDF, I would say, CDF is defined like this. F of x would be equivalent to the summation of all probabilities, but at less than, but here these xi's basically are taking the value less than equals to x. Okay, let me explain you. If you remember, I gave you an example. When we toss 3 coins together, so what would be our sample space? First of all, if we toss 3 coins together, so sample space would be head, 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 tail, 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 head, tail, okay, tail, tail, head, 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 tail, head, tail, head, and tail, head, head, and tail, tail, tail. Okay. This would be our sample space. Now, if I am interested that if we are tossing 3 coins together and I am just interested in how many heads we are getting. So this x, which is a discrete random variable, will take these 4 values. It may be the seen that we don't have any head, so in that case this x would be equivalent to 0. Okay, and corresponding probability would be 1 by 8. Why? Because in that case we will get this event. Okay, in all the 3 coins we will get tailed. The second thing may happen that we get only 1 head. So for that event, basically these are 3 possibilities in which these are 3 possibilities in which we are having 1 head. So likewise they are total 8 cases, so probability would be 3 by 8. Okay, and if we are getting 2 heads, so these are the 3 cases they can take place, and the corresponding probability would be 3 by 8. And for if we get no heads in all these 3 coins, then this would be the event and corresponding probability would be this thing. Okay, so this is our probability distribution, and if we have just written here, so this is representing the probability distribution, and here this is giving me the complete range, is giving me the probability, basically probability function or PMF. Okay, now we are learning about CDF. So CDF, how we get, according to the definition, if we am getting this CDF at a point 1, so what should be our definition? According to this, we should add all the probabilities up to this point. So that means we will add here probability at 0 plus probability at 1, and this would be 4 by 8. You can see 1 by 8 plus 3 by 8. Okay, so CDF is basically we start adding on, we keep adding on all these probabilities from this point, whatever the range is given to us, from the starting point to the last point. Okay, so this is the case how we can find out CDF. Okay, and if you see here, CDF at the last point in this range, in this experiment, would be summation of all these probabilities, and it would give me 1. Okay, so that is why the first property of the CDF is that the value of CDF is always lies between 0 and 1. So you can see here, these are the corresponding values of CDF in this particular example, and you can see all these values are lying between 0 to 1. The second property says, if x1 is less than x2, then CDF at x1 would be less than equals to CDF at x2. Okay, so what are x1, x2? Let's say suppose this is x1 and this is x2. Okay, the values which this x random variables taking. So if x1 is less than x2, so their CDFs, okay, so CDF of this x1 is 4 by 8 and CDF of this 2 is 7 by 8. So naturally you can see this value is less than 7 by 8. 4 by 8 is less than 7 by 8. Okay, the third is sometime if we are given CDFs, then we can find out probabilities. Okay, so probability of any range which is from A to B is equivalent to CDF at the last point minus CDF at the first point. Okay, but in case of this discrete random variable, from the definition, if we want to find out, suppose these probabilities are not given to us, only x random variable and CDFs are given to us. In that case, if we are interested to find out probability at a particular point, suppose I want to check what is the probability at 2, okay, at this point. So accordingly, using this definition, what should be our formula? We should look for the CDF at this point. So CDF at this point is basically CDF at 2 minus CDF at 1, the preceding number. Okay, so here CDF at 2 is 7 by 8 minus 4 by 8. So you will get your answer 3 by 8. See, this was our answer. So now you can see if PDF or PMF are given to you, so you can find out CDF, and if CDF are given to you, you can find out. So these are the vice versa. These are very closely related. That is why it is very important to learn about. Okay, I will give you a few more examples that that can be asked in your examination. So this type of questions can be asked in the examination. So let's see whatever it is written here. Just a minute. Okay, so in this example you can see a random variable x has the following probability distribution. Okay, so this is the discrete distribution you can see, because x is taking the discrete values, and this probability function basically is giving the corresponding probabilities. So question is find the value of C and evaluate the probabilities, okay, within this range from this to this, and determine the distribution function of X. So here, first of all, as we have learned that the CDF at the last point in an experiment is equivalent to 1. So to get the value of C, we can use this property. So what will we do? Basically, we know that since this when we will add all these probabilities from 0 to 4, we will add all these, so that would be equivalent to 1. So we can use this thing. So if we are adding this and after solving, this is a quadratic equation, so you will get the two values of C. C equals to 1 by 6 and minus 1. Minus 1 you cannot take because corresponding to 0 you will get negative 1, and probability in negative doesn't make any sense. Okay, so here now we must use C equals to 1 by 6. This is our answer. Okay, the second question is we are interested in probabilities. Okay, so see here, if we are interested in probability x less than 3, so that means we are interested in basically this plus this plus this. Okay, so we will add all these things, and this is giving me basically what? CDF at the point 2 last, 5 by 6. Okay, and if we are interested in this, so what should we do? Basically we should add all these things from 1 to 3. This is one way you can use. Otherwise you can make further fx here, and you can put the values, and accordingly you can use those formulas what we have learned in the previous slide. Okay, so I hope you have understood this thing. Now let's move on further, and we will understand what is the formula for CDF in the continuous random variable. So when x is a continuous random variable, then of course this is a general definition, and CDF is defined like this. Here we start taking probabilities from a negative infinity to up to that certain point x. Okay, so that is why we in that case we just add, we use summation sign in the discrete, and here we use the integration sign, because integration again gives us the sum. So limits would be from minus infinity to x up to that certain point. So and fx dx. What is fx? Fx is basically here PDF. Okay, so if PDF is given to you, you can find out CDF. This is the relation. Okay, and here now we have certain properties related to CDF. So again the first property is the same, the lies between value lies between 0 and 1, and the range in the continuous is from minus infinity to infinity. So whenever, if suppose you have any function and you have complete range minus infinity to infinity, so if you will integrate this function within this limit, you will finally get 1. Okay, so if you are getting complete area of 1, so that means this thing is defining what? CDF. Okay, and this is a non-decreasing function fx. Basically this is small fx. Okay, you must be very clear, this is small fx. We are talking about here fx, because here we keep on adding the function's value, so naturally you will get increasing function. Okay, so it is always increasing. Fine. Now the value of CDF at infinity is 1. That means we are adding this thing, then fit this thing. Okay, so the complete area gives us 1, and the CDF at minus infinity is 0 basically here. Okay, and fx is a continuous function of x on the right hand side and may have countable number of discontinuity. That means it is not necessary that you will always get a continuous function. You may get discontinuous function, but it should be very finitely divided. And the last point is very, very important, that this is PDF. Okay, PDF is equivalent to basically differentiation of CDF. So this is the relation you can use when CDF is given to you and you want to find out PDF. So what will you do? Basically you will differentiate that function and you will get PDF. Okay, so these are the properties of CDF, and now I'm taking few examples that can be asked in your examination. Okay, so here this is an example, and you can see here if the density function of a continuous random variable x is given like this. So fx is basically PDF is given to us, okay, in different range. Now the question is find the value of A, find the value of CDF of x, and find this probability. So the first question is like A is what? A is any arbitrary constant. So we'll use again the same definition, because we know that if we take the limit from minus infinity to infinity and we integrate this fx PDF, so it must give us 1. Okay. So we'll use the same concept here, and here because the range is from 0 to 4, so you can use 0 to 4. If it is not given from minus infinity to something, then you have to add, means you have to use those limits. Okay, so here the range is from, means limit are from 0 to 4. Okay, so you will integrate it and you will get the value of A. I hope you would be able to do this thing. Integration is very easy here. Now the second question is find the CDF. So that means for CDF, I just told you that this is the definition, okay, and CDF is given by like using this formula. Fine. So here we are given, we will write from, this is x less than 0. So we will again use the same interval. So in this case, earlier small fx was 0, and if we are integrating it, so again we'll get 0. In this range 0 to 2, we were having this ax. Okay, so here a is what? A is we just calculated, it was 1 by 4. So we will put the value of A and we will integrate it from lower limit to x. So in that case we will get this function. Okay, in this range the function was this. We will put the value of A first of all, and then we will integrate it. Okay, so in this case you must be very, very clear that this time we are 0 to 2 and 2 to x, because here we are finding the this CDF for the range 2 to 4. So here we will start from the lower limit to the last point. Okay, so here we have added this much, and finally at this point basically it would be 1 directly. Okay, so this is a processor. You must be very careful when you are doing this thing. Okay, because here we add the previous one also. Okay, now let's come to the third question, and here we are interested to find out probability x greater than 2.5. So the probability will be calculated from lower limit to upper limit, and upper limit in this question is 4 only. So you will integrate this thing, okay, and you will get the value. So whatever the range is given to you, if you just integrate that thing, you will get the probability. I think you have learned this thing in the previous lesson as well. Okay, so this was the previous question, but this thing is very new, and you should be very careful when you are getting CDF from the PDF. Okay, and this concept is very easy, that you are just simply adding all those integrating the function from the lower limit to the upper limit, and you are putting that thing is equal to 1. So you will get the value of a constant. Okay, so now let's move to the last question of this lesson, and here the question may arise in this form as well. Here verify the following is a distribution function. That means cumulative function is given to you. capital Fx, and this is the sign that this function will start from somewhere 0 to, and it will reach to the 1 value. Okay, so this is our distribution function, cumulative distribution function, and we are verifying whether it is a cumulative function or not. So the what would be a processor? We would find its PDF, and then we will check further if we will integrate that PDF from the lower limit to the upper limit. If we are getting 1, then that means that is a CDF. Okay, so here first of all, as I told you, we will differentiate CDF to just get PDF. So here we will do just one thing. Here we need not to be very careful. Here we will just put all the intervals, and we will differentiate the value of each interval here, and you will get the value, okay, of small f or PDF. Okay, and the finally what we have to do, we have to integrate this small fx from lower limit to upper limit, and if it is giving us to basically 1, then it is a CDF. So here we need to show that this minus infinity to infinity fx must give us 1. So in this example, you can see the lower limit start from 0 to then we have just taken 1, okay, 0 to 1, and then from this is 0 from 2 to 6, and if you integrate it, and you will get 1. So it verifies that this is a CDF of some PDF. Okay, so I hope now you can understand how these are related, PDF to CDF and CDF to PDF, and it is very important topic. You must practice the questions. I will now give you a certain exercise to for your practice. Okay, so let me summarize that we have so far learned that for a discrete random variable and for the continuous random variable, we when we have PMF, then we have its cumulative function as well, and in the case of continuous, we have probability function, and that is known the PDF especially, and again relatively we can find out its cumulative density function. Okay, so this was the lesson of today's, and I hope you have learned so many things. So please keep studying, and for any doubts feel free to contact me. Okay, thank you so much. Thank you.